Hi, welcome to Chapter 6. Chapter 6, we're going to get into writing to files and dealing with exceptions, how we can trap exceptions. Exceptions are errors. We can capture those errors before they're displayed to the user. So the editor this week is going to look a little different. Probably you should have received an email, or you can see in the Google Classroom, we now have a new editor. It's called PyCharm EDU. And I noticed we needed to have a local editor because we're writing to files. So we have to be able to write to files on our computer. If it's online, we can't write anywhere. So if you haven't done that yet, go ahead and pause this video and follow the instructions for installing PyCharm. Nice thing is PyCharm does work with Turtle, so we can open up those natively and run Turtle right within that code. So first part of the chapter starts talking about different things like word processors and image editors and spreadsheets and games, those type of things. They all need files a lot of times to keep track of data, whether it's metadata for a game, whether somebody's writing a letter, whether they're doing some kind of a spreadsheet, whatever the case may be. But we're going to write to those and read from those at any given point. We're going to have an input file and an output file. So could be one file. We could read it for input and we can write it for output. So in our code, we have to know whether we're writing or whether we're reading. So we'll know that. Now, before we can actually do anything with the file, the very first thing we have to do is we have to open the file. We have to open it. Then we can process it, whether we're going to write or read, and then we have to close it. Different types of files. In this book, we're just going to deal with textual files, but there are things like binary files, which are basically all in ones and zeros, so only the computer can read it. So, but we're not going to deal with those. So now we have a couple different types of files we can read from. One, we can read what is called a sequential file. And for those of you old enough to know how cassettes used to work when you played your music, if I wanted to listen to song number 2, I had to keep fast forwarding and play till I got to that part of the tape where I could play song number 2. What is known as direct access file, or what we call random access files, that's more like a CD. You pop your CD in, you want to hear song number 3, you can hit the next button and basically play the next song. That's song number 3. So on the bottom of page 306, it talks about file extensions, and you probably know what those are by now, but there's that three character code, sometimes a 4-character code after a file name, like .doc is a Word document. Now it's a .docx. That means it's a newer version of Word. TXT or text files, DAT or DAT files. So those are the different files that we'll be using. That can be used. We'll be using TXT files. So, so on page 307, we have what is called opening a file. So what we're going to do is we're going to have our variable. We're going to create a variable name to hold the file object. Then we have to use the word open. And inside the parentheses, we're going to have the file name that we're opening. And then what mode are we going to basically process this file? Basically, there's 3 options. There's an R for read, a W for write, and an A is a write, but it means append. Write, very, very important to let you know that when you have a file open for write, if that file already exists, it's going to wipe it out and create a brand new file. So make sure you know that before you open up a file for write, because it will wipe it out. If you do want to append to a file, then you'll use the A, and it will actually write to the very end of that file. And those are all there on page 307 in the table for modes, R, W, and A. An example at the bottom of the page is basically how we write to it. So let's just go ahead and open it up and let's talk about it. So let's open up. This new PyCharm edu. Okay, the first time opening it, it comes up and says, hey, what are your projects? So what we're going to do is we're just going to click open. And we're going to go to wherever we downloaded all those source files from. And here we are in chapter 6, and I'm going to open up file write. Now, I want you to notice that up in the right-hand corner it says analyzing. We can't do anything until we see a little green triangle right here. Okay. It takes a few minutes, but it finally appears. So we have our green check mark here. Now, before I continue on, I want to go, and there is a file called philosophers, and I am going to wipe that out. Wipe it clean. I'm going to click save. So now that file has nothing in it. So now I'm going to click on the green button here. There we go. And it says it processed. Okay. Now when I open up that philosophers.txt, we'll see those three names appear. So let's take a look at the detail of the code. And so let's see what happened here. So now you're going to see that we're always going to be checking to see if the name is equal to main. Remember, that's the default. Whenever a module is created, it always basically it sees what module is basically current running. And if the current name, we can see that this is a standalone process, it will automatically put main in there. And so now 18 becomes the first executable line, which calls main. And we create what's called, now here's where we create our file object. So our file object is out file, and we're going to make it equal to open philosophers.txt. Now, you have to know that where's that file located? It's in the same exact place this file is located right here. Now, for me, I could do this. I could go ahead and include the entire path to this statement like this. I could put G, my drive, boom, 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 put the full path in there, and that's going to run just fine. But if I leave it out, it's going to look in the same exact place this file is stored as well. So anyway, so it's going to open up that file for write. Notice the W. And then we come in here and we say output file write, John Locke. Now notice I've got a /n. If I don't put a /n in there, it's going to put all three of these names on one line. I want them on separate lines, so I want them each as their own record, and so we put the /n on there. Once we get done with that, we go ahead and close the file. So remember, so we open, we process, and then we close. And you notice that when I opened the file, those three names were there. So when we write to a file, we can also read from a file. So I'm going to go ahead and open up shouldn't take this long every time. So file read, And it's going to look very similar to the other one, which for here I've got that same if statement. First executable line is 19 main, so it calls main. It creates a file object. It says open philosophers.txt. Notice it's got the R for read. And then we say file contents equal endfile.read. Now what that does, that reads the entire file and throws everything into file contents. And so then I go ahead and close the file. So now file contents has the entire file inside of that one object right there. When I say print file contents, let's see what happens. There it prints John Locke, David Hume, Edward Burke, and it basically finished with a exit code of 0. So we got a file read. Before that, we did a file write. So before we continue, let's go ahead and do a quick class lab. I want you to go to page 350A and do file number 1. So pause this video, do that quick little class lab, kind of get used to creating, writing and reading from a file, and then unpause this video to come right on back. Okay, so when we write to a file, you'll notice that I have this John Locke and I've got a /n. So make sure you keep track of that /n because that's going to be very, very important. So here's what I want to do is I want to write, well, let's open up write names and let's talk about it. It's easier just to look at the code and then I try to not talk about it. So file open, write names. So here's what we're doing. We're going to ask the user, so again, this is the first executable line is 25, it calls main, and it says enter the names of 3 friends. So name 1, input friend 1, friend 2, friend 3. We now have 3 variables that have 3 names in it. Then I'm going to create a file object. We're going to open up friends.txt and we're going to write to it. Now if friends already exist, it's going to wipe everything out and create it fresh. And then I'm going to say myfile.write name plus a new line character, name, new line character, because if I didn't put a new line character in there, it's going to put it all on one line. Then I go ahead and close that file. So let's go ahead and run this. And we'll enter in Fred Jones, Sally Smith, and Herman Munster. I click, and it says names are written to friends.txt. So if I open up friends, it's opening, there it comes. There's Fred Jones, Sally Smith, and Herman Munster. So it worked just fine. So now let's do this. I thought I had an example of what to do here. So okay, so let's do this. Now, we got those /n's. If I were to read these files one line at a time, we're going to have a problem, and we'll see here in a second. So let's do this. Let's open up strip new line. So let's open up strip new line. And the first thing I do is I'm going to do this. I'm going to comment out these lines right here. And I just want to, we'll talk about it. So what this does is this is going to open up, it creates a file object, end file, opens up philosophers, and we're going to read each line separately. Remember how we did a read before? We read the whole thing into one object and then printed that object. Well, now we're going to read each line. So I say read line and throw it in line 1, read line, throw it in line 2, read the next line, throw it in line 3. Then I go ahead and close the file, and then I'm going to print each line, okay? So let's see what happens. Now, I want you to notice something very special here. Notice it prints John Locke, blank line, David Hume, blank line, Edmund Burke, blank line. That's because the print statement itself will print something and go to a new line. But guess what? We already have a /n built into each line of that file. So when we read it, it reads it, it sees that new line character and goes to a new line, and the print statement itself also goes to a new line. So we're basically getting that /n in there. So here's what we can do. I'm going to uncomment these lines. Now, we've got what's called an rstrip method. And what that will do is what's inside the parentheses, it will strip that off at the end, or wherever that particular character shows up in that string, it will strip it off. So I've got line 1 is equal to line1.rstrip/n. So it's going to remove the /n and then put whatever's left in that string into line 1. Does the same thing for line 2 and line 3. So now when we run this, we can see those 3 lines print. So the print statement itself prints a new line, and it basically prints a new line and goes to a new line character. So the rstrip is very important when we're reading these types of things, because we want to get rid of that extra character. It's a new line character. If I were to open up Microsoft Word, and it's coming up. And I'm just going to type some text in here. And what you're going to notice, I have special characters turned on, and you see this little weird character at the end. That's a new line character to Word. Again, I can turn that off, and we can't see it, but when I turn it on, it basically now shows that new line character. And that's what we're trying to remove when we are in Python and printing out and we're reading each line. We want to strip off that new line character. We don't want that to be included, because that can cause issues as we do reads and writes and other things like that. Also realize that if I wanted to, if I were to write names again, I'm going to open this up for A. And when I run it, I'm going to type in Bill Miller, Julie Host, and Sue Bing, and it basically wrote to it. But now, since I used the append, let me open up friends.txt. And now you'll notice Fred Jones, Sally Smith, and Herman Munster are there, and we appended to the end of it. So it didn't overwrite what was there, it appended to it. So A is how we would use that to do an append. Okay. Okay, so on page 317, we have writing and reading numeric data. Now realize that when we write anything to a file, it all gets converted to a string. So before we can take numbers and write them to a textual file, we have to convert it to a string. And we do have a great converter. It's so easy to use. Let's just open up write numbers and take a look at it. So open write numbers. So here I've got my output file object. We open up numbers and we're going to write to it. I'm going to ask the user for 3 integers. So enter a number, convert it to an int, throw it into num1, num2, num3. So they are integers. We know that because we've got int on here. But when I say output file.write, I do str, and whatever's inside those parentheses will be converted to a string. And we notice we do put the slash in at the end, so they appear on 3 separate lines. So str writes those 3 numbers out. We close the file, and that's as easy as it gets. So now when I run this, it's going to ask for a number. I'm going to type in 22, 45, and let's type in a -88. And those numbers are written to that file. So if I open up numbers.txt, there's 22, 45, and -88. Okay. Now, the same thing for writing to a file. We have to write strings. That's all we can read from a file are strings. So if we read in a numeric value, we have to also convert that back to its numeric value. So let's open up read numbers. And there I have end file. So here's my input file object. Open up numbers for R read. This time I'm going to say num equals int end file read line. So we do end file.read line, so it reads a line. We convert it to an int with 1. We do the same thing for num2 and num3. We close the file. Now this time we're going to take and total those 3 numbers together, throw them into the variable total, and then we're going to display the numbers are num1, num2, so we're using a printf, display num1, num2, num3, and then we just say their total is, and whatever that total is. Again, we're also using that if statement colon the main. Okay, so we run this. And there it is, 22, 45, and -88. We add them up, and it's -21. Okay. So, up to this point, we've just been reading and writing 2 files, just sequentially. Well, what happens if we got a huge, large file? We don't want to read 1 line at a time. You know, if there's 150, I don't want to have 150 statements reading those files. Most of the time, we don't even know how many records are in there, so we have to basically use a loop to do it. So let's go ahead and open up write sales, and then we'll explore what that guy is doing. So write sales. So let's take a look. Again, we've got our first executable line is 28 main, so we come into main. We've got num days equals input. How many days do you want to have for sales? We're going to take what they input, convert it into an int, and put that into num days. We're going to create a sales file object, which is going to open up sales.txt for write. And then we're going to use a for loop. And this time we're going to say for count in range, start with 1 for the number of days plus 1. Because remember, when we do range, it goes up to the number. Well, this time we want to do that. So if I type in a 5, I want it to go all the way to 5. I'm going to start with 1, go to 5. So I got sales.float input. So now I'm going to input from the user enter the sales for that day. We're going to use the count. So first time through it's a 1, then 2, 3, 4, and 5. If I typed in 5, we're going to convert to a float, put it into sales. Then I'm going to put sales file dot write f sales. Okay. Once we get that loop done, we're going to say sales file dot close, and the data will be written to sales. So let's run it. How many days? We'll say 3. Day 1, we'll say and day 2 and day 3. And there's data written for sales.txt. So if we open this up, wrong one. It's sales.txt, not numbers. So open up sales.txt, and you'll notice that it has those 3 numbers in there. Now, if you remember, I said earlier that all we can write to a text, we have to write text. So guess what it did? It automatically converted this right here. Sales is a float, and it converted it to a string automatically, and then wrote it to sales files. Because that's kind of what the printf does, is it converts it to a string. Now, when we read, this gets a little tricky, but it's not too bad. So let's open up read sales. And so here's, I've got sales file object is open sales txt, R for read, and then I'm going to say line equals sales file dot read line. So what I got to do is I have to read one record, because here's the problem: is Python doesn't know what an end of file indicator is. It doesn't use the end of file indicator. So what it does is when it reads a line, and that line, there's no new line, it will be a null value. So we have to deal with that null value. So what we do is we do a read first. So if that file is empty, it's going to read a null value. And notice in here we say while line not equal 2 picks side by side, that's a null value. If it's not a null value, we're going to continue on. So the first line is going to be the sales. And then we're going to say amount equal float line. So we're going to convert whatever we read into a float and put that into amount. Then we're going to print that amount. And then we're going to say line equals sales file dot read line. So here's the sales file object. Read line, we read the next line. When it comes back up here, if it's a null, the loop's over, the file is basically done, and we basically continue on. But if it has any more records, it will basically continue on and take that line, convert it to a float, put it into amount, and then print it, read the next line. So it's going to keep doing that as long as it's got lines. Once it's out of lines, it's going to close the file. And then that function is closed, is over, and it basically comes down here, and notice there's no more lines, and it stops running. So let's run this. And there's those 3 numbers we typed in the previous program. So I was able to read them and display them. Now, we're using a while loop here. There's a little easier way to do this. So let's open up read sales 2. And this time we're going to use a for loop. So look at the difference between these two guys. Look at all of this. Don't read the comments, but look at this while statement here as opposed to this for loop. We don't have to do a pre-read. We don't have to do a pre-read before the loop. We just say, so we open up our file for read, and then we say for line in sales file. So it's basically saying grab the first line or grab the next line in sales file. So if it's the first time in, it's going to grab the first line. And if it exists, it's going to go into this loop. If that file is basically a null value, it's going to drop completely out of that loop and close the file and go on. But if there is data in that line, it's going to put that into, it's going to read that line and put it into the line object. We come in here, we say float line, so we convert line into a float, put it into amount, we print the amount. Once it reads all the records, when this for loop is basically now false, we're going to basically close the file and then the program's over. So we should see the same exact results when we run this. So I click run, and sure enough, there's the 3 lines, and it basically done. So you can see it's a little easier to do with that. So let's go ahead and pause this video right here, and I want you to go to page 358 and do number 7, the random number writer. Once you get done, come back here and unpause the video. Next program is kind of like I said before, I really like the in the spotlight because they kind of give a little scenario of what's going on, and then how we basically how we accomplish what they need done there. Because Kevin is a freelance video producer who makes TV commercials for local businesses. When he makes commercials, he usually films several short videos. Later, he puts these short videos together to make a final commercial. He has asked you to write a program for the following 2 programs. A program that allows him to enter the running time in seconds for each short video. The running times are saved to a file. A program that reads the contents of the file, displays the running times, and then displays the total running time of all the segments. So the very first thing we have is save running times. So let's open up save running times. So again, it looks like we just have our main. Our first executable line is 24, calls the main, and here we create a variable called num videos. We ask the user to input how many videos there are. We convert that to an int and throw it into num videos. We create a video file object by opening up the videos times.txt for write. Again, if it doesn't exist, it's going to create it new. If it does exist, it's going to wipe it out. We go ahead and say print, enter the running times for each video. We're using a for loop this time. We're saying for count in range, starting at 1 for the number of videos plus 1. Because remember, range goes up to that number. So if I typed in 5, num videos is 5, and if I just use range, it's going to go up to 5, which is 4. But I want it to go all the way to 5, so I'm going to add 1 to it. So runtime equals flow input, so I'm going to ask the user for the video count. So the first time through is a 1. So input the video number 1. It's going to convert it to a float, put it in a runtime. Then I say video file.write, and I'm going to use a printf, which pretty much converts it to a string and then writes it to the file. And it's going to do that how many times we type for the number of videos up here. Once that loop is done, it closes the file and the program's over. So let's run it. And I want to say there's 4 videos, and the runtime for the first one is 98 minutes. I forgot, it said running time in seconds. So I want to do longer than that. So we'll say it's 240. We'll say 698, 752, and 471. And so now they've basically been saved to the file. And so if I were to go to video times and open that, we would see, yep, there is our 4 numbers. And notice it's got the 0.0 at the end because it is a float. So now let's open up read running times. So this time we create a video file object again. We open it for the video times.txt for read. Now we're going to have an accumulator, so we create a variable called total. And remember, when we have an accumulator, we have to initialize it to 0. We can't add anything to null, so we have to have it set to 0 if we're going to add to it. We're going to create another one called count. We set it to 0. We got 4-line in video file. So again, this says I'm going to read a line in the video. I'm going to read the next available line in the video file. If it's there, it's going to go into the loop. If there's nothing there, the loop ends and it goes out. So when it goes into and reads, it's going to, that line is a line read. We convert it to a float, throw it into runtime. We see count plus equal 1, so we add 1 to count. We print video count runtime. And then we say total plus equal runtime. So we're adding it to the total. And so we do that for each one. So we're displaying the runtime by the video number. We add it to the total. And then once that loop is done, we close the file and we print the total running time is the total in seconds. And realize total is a local variable to main, so only main can see that. So just be aware of that as well. And that's the only function in here, so it really doesn't matter. So let's run this. And there it is. Here are the running times for each video. 240, 698, boom, boom. And it says the total running time is 2161.0. Probably could have done this. And I might have made it look a little better. Yeah. I forgot to my comma separator in there. There we go. Comma 0.2f. And now let's run it. So now it shows 2161.00. Okay, so we're learning a lot here. So on page 328 talks about processing records. Now the very first thing we're going to talk about is what is a record. So if you think of, let's say you're entering data on a website for all about you. Well, you're going to print in your first name, your last name, your address, city, state, zip, maybe your ID, maybe your account number, all these different fields. So those are called fields. So first and last name, that's 2 separate fields. Street address, city, state, zip, those are all fields. You put them together, that makes up a record. So that record is going to have first name, last name, street address, city, state, zip, account number, and whatever fields basically go along with that. And so we want to be able to do the same thing here. Top of page 329, they have an example of a record that exists of name field, ID number field, and department number field. And what's nice about that, when we do that, if you look down on records on a file, we can see each one of those records, and there's 3 fields per record. So let's open up Save Employee Records. So first thing it asks us, hey, how many employees do you want to have records for? We take that number, convert it to an int, throw it into num imps. And then we create an emp file object by opening up employees.txt for write. And then we're going to have a for loop for a count in range 1 to num employees plus 1, because we want to go all the way up to that number and not just before it. And we're going to say enter the data for employee, and the first time through is 1. And we're going to say name, input name, ID number, input ID number, department, input department number. And then we're going to write the name, ID number, and department. Notice we got a /n on the end of each one. And then we print it. And then we say employee records are written to, so once that's done, we close the file and we print employee records are written to the employee. So again, we only have one functions, and that was called on line 34. So let's run this. And let's go ahead and create 3 employees. And we'll call it Bill Shepler. ID number is A123. Department is IT. The second person is Sally Ride. ID number is B123. They are in accounting. The last person is George Jetson. And ID number is C123. And they are in executive. And we get done. Now, if I open up employees.txt, we're going to see probably 9 lines of code. Yeah, so there's 9 lines of code, 3 lines for each employee that I just created. So now we're going to read that file by opening the read emp records. So the very first thing it does is it creates an emp file object, and it opens up employees.txt for read. And the first thing it does is it reads the very first record, throws that into name, because we want to see, is there a record? Because the while loop's going to say, hey, if that's equal to a null, get out. So let's keep doing this until we hit a null. So we come in, it's already got names, so now the next line it's going to read, put that into ID number. The next line it reads is going to throw that into department. Then it's going to strip off the /n off each one of those. Then it's going to print the name. It's going to use printf. Name, it displays the name, ID, the ID num, department, and then it's going to print a blank line. We want to have it separated by blank line. Then it says name equal employee record, so it reads the next line. It comes back up. If there's another record, it continues on. Once it reads all the records, it closes the file. And again, since that's only a function and it was called by line 39, the program's over. So let's go ahead and run this. I can make that a little bigger. And there it is. There's name, Bill Shepler, ID, A123, Department IT, Sally Ride, B1. So again, everything we typed in, and it's displayed very nicely. So each one of those is a field, and all 3 of those lines together makes up a record. Okay, here's another in the spotlight, adding the displaying records. Midnight Coffee Recruiters is a small company that imports raw coffee beans from around the world and roast them to create a variety of gourmet coffees. Julie, the owner of the company, has asked you to write a series of programs that she can use to manage her inventory. After speaking with her, you've determined the file needed to keep inventory records. Each record should have a 2-record field for the following data: description, a string containing the name of the coffee, quantity in inventory, the number of pounds in inventory as a floating point number. So let's open up Add Coffee Record. So let's take a look. And yep, we only have one function, main, that's called here on line 33. First thing we're going to do is create a variable called another. We set it to a lowercase y, or well, we'll set it to a y. I can't quite tell if it's uppercase, lowercase. Looks like it's lowercase. We create a coffee file object, and we open up coffee.txt for append. So let's see what's in there right now, just so we know what we're dealing with. And it looks like it's got Sumatra medium roast 25. Okay. So it's going to append to it. And while another equals y or another equals uppercase y, so we are going to tell it when we're done by typing a no. So it is a y, so it's going to come in here and it's going to print, enter the following coffee data. DESCR, short for description, and we're going to input the description. The QTY, short for quantity, we're going to quantity in pounds. We're going to convert that to an int, throw it into quantity. Then we're going to say coffee file.write with a printf, the description /n. Remember, we have to have the /n to keep it on one line by itself, and then coffee QTY /n. And then we're going to print, do you want to add another record? Y for yes, anything else for no. Once we're done, it will close the file and it will say data appended to coffee.txt. And again, it is over. So I'm going to use the examples I have on page 333 there for the program output. So let's run this. And the exclamation is Brazilian dark roast. And we have 18 pounds. Yes, I want to do another one. And that is, we're going to say Sumatra they say medium. I think there's already a Sumatra in there. So we're going to call this Sumatra dark roast. And let's go ahead and put 15 pounds. And no, I don't want to add any more. So now, if I look at coffee.txt, I can either just Sumatra medium roast 25, Brazilian dark roast of 18, and Sumatra dark roast of 15. Now notice, since it was converted to a string, it did not include the 0.0, but we can get that back, not a problem. So, okay. So now let's show the coffee records. Let's open up Show Coffee Records. And again, we only have the one function main. It's called on line 31. And we create a coffee file object by opening up the coffee.txt for read. So we go ahead and read the very first line because we want to see if there is a record. And we'll say while description is not equal a null value. That means that we do have data. Then we go ahead and read the next line and throw it into quantity by converting it to a float first. And then we go ahead and say description equal description r strip. So we're going to remove the /n. And notice we didn't do it for quantity. Why didn't we do it for quantity? The reason being is because since we converted it to a float, it removed all that garbage. So it's just so right here when I said float, it removed all of the other garbage out of there and just converted it to a float. So we didn't have to do an r strip of the /n. So then I go ahead and print the description and the description and the quantity and the quantity. Then I go ahead and read the next line, put that in the description, and while there is, it's going to go through this loop again. It's going to keep doing that till it hits the end, and then we're going to basically close the file. So let's run it. And there it is. Sumatra medium roast, 25, Brazilian dark roast 18.0. Notice I added the 0.0. And description, Sumatra dark roast 15.0. So now, so on page 334, Julie's been using the first two programs you wrote for her. She now has several records stored in her coffee.txt file. She has asked you to write another program that she can use to search records. She wants to be able to enter description and see a list of all the records matching that. So let's open up Search Coffee Records. And let's see how this works. So again, looks like we have just one function, main, and it's called there on line 49. Very first thing we do is we create a Boolean variable called found. We set it to false. We create a search variable and we input what description do you want to search for. Okay, so whatever you want to search for is going to be put into that variable. We create a coffee file object by opening up the coffee.txt for read. We go ahead and read the very first line of the description, equal coffee file.readLine. And it says while description is not equal a null value, so while we have data, we're going to read the next line, quantity, convert it to a float, put it in there. We're going to strip off the /n off the description. So this is pretty much just like the previous program up to this point. Here's where it gets different. Now we say if description equal, remember the double equal sign is an equal. We're checking to see if they equal. It's a Boolean check. So if description is equal to search, we're going to print description and the quantity and then print nothing. And we're going to say found true and all it does then is just read the next record. So found true. Once done with that loop, okay, I see. I found this used down here. I was trying to where was that the found used at? So it could actually find multiple records with that same search criteria. So it's going to print them, and then we're going to go ahead and close the file once we're done with the loop, and we're going to say if not found, that item was not found in the file. But if it was found, it's already printed. Okay, so I'm going to go ahead and make this easy on myself. I'm going to copy this Brazilian dark roast down here, do a Control-C, and let's run it. And I'm going to do a paste right here. And there it says, description, Brazilian dark roast, quantity 18. Pretty cool. And if I run it again, and this time I'm looking for Folgers, it says the item was not found.